NASA is building a camp. China and Russia, they're laying bricks. But SpaceX is flipping rockets into moon bases, literally. While others are dragging prefab modules or melting lunar dust into bricks, Elon Musk has a wild idea. Why build a house on the moon when your rocket can be the house? This is Moonbase Alpha, SpaceX's plan to turn deep space living into something fast, scalable, and, frankly, way cooler. No construction crew, no waiting years. Just land it, tip it, retrofit it, and boom, home. In today's TechMap video, we're diving into why SpaceX's Moonbase Alpha might just leave NASA and China in the lunar dust, and how it's redefining what it means to live on another world. We all know SpaceX is ramping up its cutting-edge technology to help NASA make a return to the moon a reality. NASA's ambitious international project, the Lunar Gateway, has been making headlines for good reason. This will be the first space station orbiting the moon, and is a cornerstone of the Artemis missions. It's not just about getting astronauts back on the moon. It's about laying the groundwork for future crewed missions to Mars. The Gateway will serve as a deep space home for astronauts, giving them a place to conduct science and prepare for missions down to the lunar surface. To ensure everything's ready for Artemis 4, the first crewed mission to Gateway, NASA is aiming to launch two key components by December 2027: HALO, Habitation and Logistics Outpost, and the Power and Propulsion Element. Both modules will hitch a ride aboard a SpaceX Falcon Heavy rocket. Then, in September 2028, under Artemis 4, SpaceX's Starship human landing system will transport astronauts from Gateway down to the lunar South Pole. It'll also play a vital role in delivering supplies for crewed missions. And even before that, Artemis 3, planned for 2027, will see a Starship land astronauts on the moon. Clearly, SpaceX isn't just providing support, it's central to the mission's logistics. But let's be real, Elon Musk didn't build the world's most powerful rocket just to play a supporting role. Starship is meant to take center stage. And that brings us to the bigger picture of lunar exploration. While NASA's primary moon base, called Artemis Base Camp, is focused on fixed surface habitats prefabricated on Earth, and China is exploring 3D printing structures using lunar soil, Elon has a different idea. He sees Starship as a mobile lunar home, simple, flexible, and innovative. Think about it. Instead of hauling huge modules or tons of building material to the moon, why not just use the transport vehicle itself as the habitat? It's practical and efficient. For these lunar missions, the Starship won't need wings or heat shields, since it's not coming back to Earth. These specialized versions will stay on or orbit around the moon permanently. And they won't just be functional, they'll look good too, possibly painted white rather than left in raw stainless steel. Much like a submarine, Starship's internal structure will be transformed from a vertical layout to long horizontal decks extending from the nose to the tail. To achieve this transformation, several steps are necessary. After landing vertically on the moon, the Starship will be physically tilted over into a horizontal position to serve as a habitat. Following this, the most complex phase begins: interior renovation, which can be assisted by robotics. Initially, Starship was designed for short-term crew support, functioning like a mobile home. But to serve as a long-term trailer park on the moon, its interior will need a full makeover, converting it from a transport vehicle into a permanent living space. So what does a home really need? For starters, floors and walls to divide rooms. It also requires electrical wiring, ventilation, communication systems, lighting, heat management, plumbing with water tanks, bathrooms, showers, and furniture. The goal is to keep the layout simple but effective, maximizing both comfort and usability. Inside, Starship will likely follow an open concept design, with a single-level floor running from front to back, roughly 1/3 up the rocket's circumference. This configuration allows for storage and equipment under the floor and provides enough overhead space to reduce claustrophobia for the crew. The ship's length can then be divided into sections for various essential functions: living quarters, dining areas, scientific laboratories, exercise zones, and maintenance workstations. Living quarters would focus on privacy, comfort, and rest for each astronaut. Sleeping areas could be modular pods or small rooms designed to reduce noise, control light, and maintain circadian rhythms despite the Moon's unusual day-night cycles. Communal dining and social zones help support crew morale and mental health. These spaces would include kitchens or food prep areas, supply storage, water recycling systems, and areas for relaxation, games, or virtual communication with Earth. Dedicated science areas would support experiments, equipment maintenance, and physical exercise. Labs could be used for tasks like analyzing geological samples, conducting biology experiments such as plant growth, and carrying out engineering work vital for operations on the Moon. Exercise equipment is crucial to counter the effects of low gravity, such as muscle weakening and bone density loss. Workstations may also include robotics control areas for managing remote machinery used in construction and repairs, essential for keeping the habitat functional. Because the environment on the Moon is so unique, specialized systems are required throughout the habitat to keep astronauts safe and comfortable. These include air circulation to keep oxygen moving, climate control systems to maintain appropriate temperature and humidity, water recycling systems to reuse water efficiently, and waste management systems to keep the habitat clean. The Starship base will be modular, allowing easy upgrades or reconfigurations as mission needs change. Its life support systems will operate in a closed loop, conserving essential resources like air and water to make the base more sustainable. Instead of traditional rocket fuel, this lunar starship will be powered by 5 large solar panels arranged in a hexagon, covering about 60 feet, 18 meters in diameter. These panels will provide most of the energy required to operate the base. The design also puts a strong emphasis on astronaut mental health. Private quiet spaces, LED lighting that mimics natural daylight, and intuitive ergonomic designs all contribute to making life on the Moon more manageable. Finally, once construction is finished, the lunar starship base will need protection from space hazards. While there's no wind or rain, the Moon is bombarded by meteorites and cosmic radiation. The solution? A 5-meter-thick layer of lunar regolith covers the starship, acting as a protective shield against both radiation and small impacts. To sum it up, SpaceX's Alpha Moon Base introduces a novel concept, transforming the Starship landers themselves into fully functional habitats for living and working. The idea is simple yet groundbreaking. You bring almost everything you need from Earth inside the rocket and then use lunar soil to shield it once it's landed. This approach takes advantage of the vehicle's existing structure, upgraded with solar panels and interior modifications. It's fast, efficient, and practical. Despite its efficiency, other space agencies have opted for different strategies. They favor designs that aren't limited by the requirements of launch or landing vehicles, and instead focus on custom-built surface habitats tailored specifically for life on the Moon. China and Russia are collaborating on a major lunar research project called the International Lunar Research Station. The construction approach is highly advanced, utilizing local lunar resources to build habitat structures. This includes cutting-edge 3D printing technology and machines that create bricks by melting and shaping lunar soil. These bricks, intended for protective outer layers and base infrastructure, have already undergone testing on Earth and in simulated space environments. By constructing much of the base using Moon materials instead of importing everything from Earth, they significantly reduce both costs and payload weight. Much like SpaceX, China will employ robotic systems for support. Robots and autonomous machines will play a crucial role in constructing, maintaining, and expanding the base, particularly in coping with the moon's harsh conditions. The habitat design will feature a combination of rigid modules and inflatable softshell sections. These, along with the lunar soil bricks, will offer protection against radiation, extreme temperatures, and micrometeorite impacts. The base will include a network of connected modules built for long-term human use, such as living quarters, labs, and work areas. For life support, China plans to cultivate plants to produce food and recycle air and water, using the proven Lunar Palace system. This Earth-tested setup is designed to model a self-sustaining life support environment, suitable for long-duration lunar missions. The Lunar Palace system can even create a bioregenerative life support system, recycling oxygen from plants, purifying water, and processing waste into nutrients to grow food. At the heart of NASA's Artemis Base Camp is the Foundation Surface Habitat, a purpose-engineered fixed module intended to serve as the astronauts' core living and lab space. The Foundation Habitat offers 127 cubic meters of habitable volume. While that's only about 1/10 of the International Space Station's volume, it's a significant space for a structure located in deep space. In fact, it's 10 times larger than the Orion capsule, which transports astronauts to lunar orbit, and even more spacious than the entire Gateway space station. Designed to accommodate up to 4 astronauts, the habitat supports stays ranging from several weeks to about 2 months. It's a multi-story facility, roughly 3 levels, that includes everything needed for extended lunar living. While the habitat remains stationary, astronauts will move around using specialized vehicles. These include the Lunar Terrain Vehicle, an unpressurized rover for short-distance travel around the base, and larger pressurized rovers designed for longer journeys lasting days or even weeks. These rovers are equipped with life support systems to keep astronauts safe during extended surface missions. Like SpaceX, NASA's base camp will rely on solar energy and may even add nuclear power sources for a continuous energy supply. Energy storage and management systems are essential to get through the lunar night, which can last about 14 Earth days. Whereas Starship uses a thick layer of lunar regolith and internal insulation for radiation and thermal protection, NASA's Artemis Base Camp features thick, purpose-built walls. The habitat may also incorporate underground or partially buried structures for additional shielding. One of the exciting aspects of the base camp is its scalability. It's designed to grow over time, starting with initial modules and gradually expanding. Thanks to its modular components, it's easy to add new labs, living spaces, or infrastructure as needed. On September 12, 2024, SpaceX ignited global excitement with a historic and emotional achievement, the first ever commercial spacewalk, showcasing its cutting-edge new EVA suit. This landmark event wasn't just for show, it served a critical purpose. The mission aimed to rigorously test the new suit's mobility and its ability to protect astronauts in the vacuum of space and under intense radiation. While SpaceX hasn't officially shared the test results, what we saw speaks volumes. The suit performed impressively. This moment marks a giant leap forward toward Elon Musk's ambitious vision of making humanity multiplanetary. But SpaceX wasn't the only one making headlines. Across the globe in Eastern Asia, the China-manned space agency wasn't far behind. Just roughly 2 weeks after the Polaris Dawn mission, China unveiled its own next-gen lunar spacesuit, a bold statement that it's ready to land on the moon by 2030. This new suit, set to be worn during future moonwalks, visually resembles NASA's classic EMU suits, with its iconic red and white color scheme. Packed with innovation, China's lunar suit is engineered to tackle the moon's brutal conditions. According to reports, it features both long and short-range cameras, an integrated operations console, and a massive oxygen supply backpack. One standout element is its glare-proof panoramic helmet visor. This feature isn't just for looks. It protects astronauts from the blinding sunlight bouncing off the lunar surface, enhancing visibility and reducing eye fatigue during critical tasks. Delving deeper, research suggests the suit is made from advanced materials that insulate astronauts from the moon's extreme temperature swings, from blistering heat to bone-chilling cold. It also offers protection against lunar dust, known for its abrasive nature that can quickly wear down gear. This means more durability, longer missions, and fewer suit failures. In a demonstration video, an astronaut showcases the suit's mobility against a space-themed backdrop. Every movement, from walking to bending, highlights the suit's thoughtful joint design and ergonomic construction. It's clearly built for functionality under reduced gravity, ensuring astronauts can perform complex tasks without feeling restricted. That said, there's been some online chatter comparing the two nations' suits. While China's design checks many boxes, some viewers noted its bulkier appearance compared to SpaceX's sleek, light, and futuristic aesthetic. One comment joked, "Why does this look like me when I'm on the verge of taking a massive shit?" Another added that China's suit felt like a throwback to old-school NASA, whereas SpaceX seems to be stepping into the next era of spacewear. So, how about you? Are you impressed with the new Chinese spacesuit? Let me know in the comments section below. Anyway, if you love this deep dive, smash that like button, hit subscribe, and ring the bell. We're aiming for 150,000 subscribers, and we need you to get there. Regardless of the memes, one thing is clear. We are witnessing a new golden age of space exploration, with multiple players pushing the boundaries of what's possible. And the race to the moon, and beyond, just got a whole lot more exciting. China's latest move has stunned even the most seasoned experts in the field. One of them is Canadian astronaut Chris Hadfield, who took to X to comment on the momentous reveal. China has stated their astronauts will be walking on the moon by 2030. They just revealed their new suit. The reveal also caught the attention of none other than Elon Musk. At the time, the SpaceX CEO was battling what he called Kafkaesque paperwork, referencing the kind of absurd bureaucracy made famous by novelist Franz Kafka. Responding to the video of the Chinese suit on X, Musk didn't hold back. Meanwhile, back in America, the FAA is smothering the National Space Program in Kafkaesque paperwork. That single tweet wasn't just a jab. It opened the floodgates. Musk was drawing a sharp contrast between China's rapid progress and the United States' bureaucratic gridlock. His post echoed growing frustrations in the private space industry, especially as his own company, SpaceX, was hit with hefty fines by the FAA. In September 2024, SpaceX wrote a scathing letter to the U.S. Congress, accusing the FAA of being too slow and under-resourced to handle the booming commercial space sector. According to the letter, delays caused by the FAA's slow pace directly threaten national priorities. At the center of the dispute was Starship, SpaceX's next-gen rocket system designed for deep space travel. Despite being fully built and ready for its fifth test flight since August, the FAA had pushed its next possible launch date to no earlier than November. Musk was furious. The FAA leadership spends their resources attacking SpaceX for petty matters that have nothing to do with safety, while neglecting real safety issues at Boeing. This is deeply wrong and puts human lives at risk. Enough is enough. His frustration wasn't without context. SpaceX had just stepped in to rescue NASA astronauts Sunita Williams and Barry Wilmore from the ISS when Boeing's Starliner ran into issues.
Yet despite stepping up, the FAA fined SpaceX $633,009 for alleged safety violation.
In its defense, SpaceX laid out detailed facts in the letter, insisting it remains absolutely committed to safety in all operations. The company also accused the FAA of relying on false reporting and superfluous environmental analysis to justify delaying Starship's launch. Just to underscore the absurdity, Musk declared on X, "Flight 5 is built and ready to fly. Flight 6 will be ready to fly before Flight 5 even gets approved by the FAA." For a long time, Elon Musk has openly praised China's rapid rise in space technology. Way back in 2019, when the Chinese space station Tiangong-2 was preparing for a controlled descent from orbit, Musk took to X to express his admiration. He wrote, "This is actually a good thing, by the way." China is making amazing progress in space, rapidly iterating on rocket and space station technology. Great respect. Tiangong 2, which means Heavenly Palace, was launched in 2016 and served as a testbed for technologies that would power China's future permanent space station. It was never meant to stay in orbit long-term and was successfully deorbited on July 19, 2019, splashing down safely in the Pacific Ocean between New Zealand and Chile. While it was modest in size, far smaller than the International Space Station, it represented a major stepping stone toward China's long-term space ambitions. Fast forward to 2020, and China was making headlines again. A report by Space News revealed that China was developing smart, recoverable, and reusable launch vehicles. These weren't just rockets. They were being designed to learn, adapt, and come back for another flight. At the heart of this push was the Long March 8, a rocket designed for vertical takeoff and vertical landing, much like SpaceX's Falcon 9. Built by the China Aerospace Science and Technology Corporation, CASC, it runs on a kerosene liquid oxygen mix and builds on tech from the Long March 7. Meanwhile, the Shanghai Academy of Spaceflight Technology, SAST, another arm of CASC, was working on a reusable Long March 6. What's really interesting is that Chinese private companies weren't content to sit back and let state-run organizations lead the way. Beijing-based Landspace and iSpace started developing methalox-fueled rockets that can land vertically using advanced variable thrust engines. Then there's Galactic Energy, a rising star among the second wave of Chinese space startups, also working on a fully reusable launcher. This shift didn't go unnoticed by Elon Musk, who was clearly impressed. He tweeted, "China understands the profound importance of reusability. The era of expendable rockets will soon be over." Reusability is truly considered the holy grail of the rocket industry by drastically lowering launch costs, increasing launch frequency, and enabling rapid rocket turnaround. Reusability is the holy grail of space travel. It brings down costs, increases launch frequency, and allows for faster turnaround times, something SpaceX has mastered with its Falcon 9, which has been launched 515 times over 15 years, with 512 successful missions, giving it an astonishing 99.42% success rate. Earlier this year, Musk proudly declared, SpaceX will launch over 90% of all of Earth's payload mass to orbit this year. But China isn't far behind. With reusable variants of the Long March series and innovative rockets like Landspace's Zhuke 3, China is building a diverse and competitive launch ecosystem. The nation now ranks second globally in terms of both the number of launches and total payload mass delivered to orbit. And if Musk's predictions hold, here's how the future might look in terms of orbital dominance. China will be roughly 5% and rest of world, including rest of America, around 5%. That leaves a staggering 90% of the world's orbital payloads to SpaceX, at least for now. But the race is on, and it's more competitive, thrilling, and globally transformative than ever before. China's ambition to dominate the moon is no longer a secret. It's now clearer than ever. An article titled, "China to Perform Crewed Lunar Landing Before 2030, Chief Designer," shared by astronaut Chris Hadfield, put the spotlight on Beijing's bold lunar roadmap. Elon Musk himself chimed in with a powerful statement. The China space program is far more advanced than most people realize. According to Wu Weiren, chief designer of China's lunar exploration program, China is rapidly advancing toward completing its Phase 4 lunar exploration program. And they're not just aiming to visit, they want to stay. Let's break it down. As of 2022, the China National Space Administration, CNSA, outlined a plan to begin the fourth phase of the lunar probe program, including the launch of 3 missions dubbed the Chang'e 6, Chang'e 7, and Chang'e 8, and the construction of an international lunar research station on the moon. Chang'e 6, scheduled for launch around 2024. This mission will attempt something no one has ever done: collect lunar soil samples from the far side of the moon. Chang'e 7, heading for the moon's south pole, this mission will search for traces of water, which is a potential game-changer for long-term lunar survival. Chang'e 8, launching around 2028, this mission will work alongside Chang'e 7, to begin building an international lunar research station, focusing on testing how we might extract and use lunar resources. That's not all. To support all this activity, China is also launching the Queqiao 2 communications relay satellite in 2024, ensuring robust communication between Earth and missions operating at the Moon's south pole and its far side, areas that are notoriously hard to reach with direct radio contact. The goal is clear. China isn't just planting a flag. They're building the infrastructure for a long-term lunar presence. With cutting-edge technology, a clear timeline, and growing international interest in collaboration, China is on the fast track to turning the Moon into the next frontier of global competition. And with Musk calling attention to their progress, you know this isn't hype, it's a wake-up call. The new space race is real, and it's happening right now. In 2022, after Western countries imposed sanctions on Russia for its invasion of Ukraine, Russia decided to stop supplying rocket engines to the United States. Dmitry Rogozin, then head of Roscosmos, declared that Russia would no longer sell or maintain the RD-180 and RD-181 engines used in American rockets. This move wasn't exactly welcomed news in the U.S., especially since the RD-180 was the powerhouse behind the Atlas V rocket, a mainstay for the ULA, and a key player in carrying out top-secret missions for the Department of Defense and the National Reconnaissance Office. Although SpaceX had already begun handling DoD missions, many earlier contracts and mission-specific needs were still tied to the Atlas V. Additionally, the RD-181 engine powered Northrop Grumman's Antares rocket, which launched Cygnus cargo ships to the International Space Station. Understandably, this stirred concerns. Many feared Rogozin's move could jeopardize the decades-long collaborative space partnership between Russia and the United States, especially around ISS operations. Yet Rogozin himself seemed unfazed. In fact, he mocked the situation, quipping that American astronauts might have to ride broomsticks into space. Fast forward just 3 years, and the US proved it had plenty of broomsticks thanks to SpaceX. In 2022, the Falcon 9 rocket flew 61 missions. In 2023, that number jumped to 91. By 2024, Falcon 9 reached an astonishing 132 launches. Meanwhile, Russia's own broomstick has yet to leave the drawing board since it was first unveiled in 2020. Trying to catch up with the American lead in reusable rocket technology, Russia rolled out its own Falcon 9 cloned project, the Amur SPG. Like Falcon 9, the Amur SPG is a partially reusable rocket. Its first stage is built to land vertically and fly again, while the second stage is expendable. The Amur SPG uses 5 RD-0169A Methalox engines, burning methane and liquid oxygen, designed by the Chemical Automatics Design Bureau. These engines are engineered for durability. Most are expected to handle up to 100 launches, and the center engine, used for landing, is being tested for 300 uses. The rocket also includes grid fins and landing legs, clearly echoing SpaceX's design choices. One notable upgrade from Russia's traditional Soyuz rockets is the shift to methane as a fuel. This mirrors the design strategy behind SpaceX's next-gen Starship and represents a move toward more sustainable, reusable propulsion. Methane is not only cleaner and more efficient, but it also supports potential future missions to places like Mars, where methane could be sourced locally. The Amur SPG project also aims to implement cutting-edge manufacturing techniques, like composite materials, 3D printing, and bionic structural design, to make the rocket lighter without compromising its strength. Safety hasn't been overlooked either. The rocket's control system is built to adjust engine thrust during a malfunction and steer the rocket away from the pad in case of failure, ensuring higher reliability. However, the Amur SPG's payload capacity is much more humble than Falcon 9, with only 10.5 tons to low Earth orbit in its reusable form and up to 12.5 tons in an expendable setup. At least both outperform the Soyuz 2, which maxes out at 8.5 tons. Roscosmos wants the Amur SPG to launch for just $22 million, a bold contrast to the price tag for a Falcon 9 launch. This makes sense because Russia's payload capacity is half of SpaceX's. The preliminary design phase kicked off in October 2020, with a projected budget of around 70 billion rubles, or roughly $880 million. The name Amur SPG draws from its connection to the Amur River region and the Progress Rocket Space Center in Samara, both of which play a crucial role in Russia's storied rocketry legacy. Switching to methane as a propellant and incorporating a reusable first stage was seen as a strategic move to make the Amur SPG more affordable and globally competitive. With Amur SPG, the Kremlin hopes to regain a foothold in the commercial launch business and even beat SpaceX's rocket, as Rogozin said. Of course, we are looking at what our American colleagues are doing. But our engineers are trying to take a shortcut, not to repeat what our SpaceX colleagues are doing, but surpass them. He added that he was not impressed with the SpaceX spacecraft, saying its landing was rather rough. It's not designed for ground landing. That's exactly why American colleagues chose to land on the water the way it was done 45 years ago. Anyway, if you loved this deep dive, smash that like button, hit subscribe, and ring the bell. We're aiming for 150,000 subscribers, and we need you to get there. To respond to Roscosmos's words, SpaceX CEO Elon Musk offered them some tips on reusable rockets. He said Russia's move to build a reusable rocket booster by 2026 is a step in the right direction. It's a step in the right direction, but they should really aim for full reusability by 2026. Larger rocket would also make sense for literal economies of scale. Goal should be to minimize cost per useful ton to orbit, or it will at best serve a niche market. Elon's post followed the post of Ars Technica space reporter Eric Berger, which rightly pointed out that Amur SPG's design seems uncomfortably recognizable. Russia has clearly decided that if you can't beat them, join them with its new design for a reusable booster, he wrote. Alas, no flights until at least 2026 means it will be at least 15 years behind the Falcon 9. Russia is lucky SpaceX doesn't innovate, huh? These posts came just 7 months after Russia stopped providing rocket engines to the US. But there's a massive elephant in the room. Roscosmos's progress has been painfully slow. As Eric Berger put it 5 years later, Russia wants to have a Falcon 9, but 13 years after Grasshopper, all they have are renderings. This quote sums up Russia's technological lag in developing reusable rockets. On March 10, 2023, Roscosmos signed a government contract to begin the technical design phase of Amur SPG. However, since then, little progress has been made. No hardware, no test flights, just digital renderings. Initially, Moscow had aimed for a 2026 debut launch. That's now been pushed to nearly 2030, and even that timeline is being met with skepticism. So what's causing the delay? First and foremost, there's the impact of sanctions and economic constraints. Between 2013 and 2020, Russia poured nearly $50 billion into its space program. But since 2014, and even more so after the Ukraine war, Western sanctions have wreaked havoc. Financial deficits, blocked access to advanced technologies, and a dwindling talent pool are just some of the setbacks. On top of that, Russia lost significant revenue from halting sales of Proton rockets, RD-180 engines, and Soyuz launches. For instance, the OneWeb withdrawal alone dealt a major financial blow. Roscosmos's annual budget was expected to grow by 5 to 10%, but with external pressures mounting, that's hardly enough to cover the cost of ambitious programs like Amur SPG. With limited resources, funds are being spread too thin across various projects. History doesn't help either. The canceled Kuiper spaceplane, 2006, and the unrealized Russia-China space station, announced in 2008, slated for 2015, highlight a recurring problem. Russia struggles with long-term project execution. Given this track record, a 2030 launch for Amur SPG seems overly optimistic. The reality might be that the agency is prioritizing current obligations, like maintaining ISS operations or supporting military space projects, over groundbreaking new ventures. Then there's the issue of supply chains. Sanctions have cut Russia off from space-grade electronics and advanced manufacturing equipment, tools that companies like SpaceX have easy access to. Without them, testing and production grind to a halt. And finally, let's address the conspiracy theory. Is Amur SPG just propaganda? Some analysts argue that the rocket renderings aired on Russian TV are more about optics than engineering. It wouldn't be the first time the Kremlin has showcased grand space ambitions without immediate plans to deliver, something reminiscent of Soviet-era PR tactics. Okay, now let's talk about how the Soviet Union turned its space program into one of the most sophisticated and sometimes downright theatrical PR shows of the 20th century. First off, picture this. It's the late 1950s. Cold War tensions are sky high, and suddenly Sputnik pops into orbit. Boom! The world's first artificial satellite. The USSR didn't just announce it. They crafted a narrative that screamed, "We're winning. We're technologically superior. We're leading mankind into a new era." Sputnik wasn't just a satellite. It was propaganda gold. Then came Yuri Gagarin, the first human to orbit Earth. And the media frenzy that followed was on another level. Soviet officials didn't just market him as an astronaut. He was the new Soviet man, a symbol of the ideal citizen. Brave, humble, loyal to the party, and the embodiment of socialist progress. His face was everywhere. Posters, stamps, newspaper covers. Even children's books celebrated him as a hero destined to inspire generations. But here's the kicker. While the West was bragging openly about their space programs, the Soviets played it like a secret weapon. Information was tightly controlled. Failures were buried deep, missions shrouded in mystery, and details revealed only after guaranteed success. It was almost like a magic trick, always keeping the audience guessing until the big reveal. This wasn't just about looking cool on the global stage, though that was a huge bonus. It was political theater meant to prove that socialism wasn't just an ideology, but a scientifically and morally superior system that could lead humanity into the stars. However, that PR strategy doesn't really hold up anymore. It's clear to everyone that Russian space technology has fallen far behind SpaceX, and the Amur SPG project is still just a digital concept with no real-world progress to show for it. On July 28th, SpaceX CEO Elon Musk shared on X that Starship Flight 10 is set to launch next month. Coinciding with that announcement, Ship 37, the upper stage hardware for Flight 10, was rolled out to Pad A and lifted onto a specially adapted transport stand. Just 2 days later, the vehicle was loaded with propellant for the upcoming static fire testing, scheduled to take place soon. It is a major milestone as SpaceX gears up for the testing next month. Now, there's something particularly noteworthy about this upper stage. Just a few hours after arriving at Pad A, Ship 37 made history by becoming the first Starship to be stacked directly onto the orbital launch mount using what's being called the Star Stool, essentially an improvised static fire stand integrated into the OLM. Why this change in procedure? It all goes back to a major incident involving Ship 36 on June 18th. During a static fire test at SpaceX's Massey test facility, Ship 36 suffered a catastrophic failure, likely due to a composite overwrapped pressure vessel issue in the nose cone. The resulting explosion caused severe damage to Massey's infrastructure, destroying the ship, the test stand, and much of the surrounding propellant equipment. Since then, the Massey site has been out of commission, and for the foreseeable future, it will likely only support cryogenic tests. Faced with that setback, SpaceX quickly pivoted. Instead of waiting for Massey to be rebuilt, a process that would take a considerable amount of time, engineers devised a workaround. They retrofitted the OLM at Pad A to support static fire tests by integrating an empty ship transport stand directly into the structure. This creative and rapid solution is allowing the team to keep testing timelines on track and continue pushing toward the next Starship launch. After rolling out S-37 to the launch pad, SpaceX wasted no time getting it stacked on the OLM, with static fire tests expected to begin shortly. This quick turnaround is a clear example of SpaceX's fast-paced, no-time-wasted approach to development. Another great example of this rapid workflow is their strategy of parallel development and testing. While work continued on Ship 37, SpaceX was also making steady progress on other Starship prototypes, like Ship 38, which is slated for Flight 11. The vehicle completed the cryo test on July 30th. By developing multiple vehicles simultaneously, SpaceX ensures there's always hardware in the pipeline, reducing delays caused by setbacks with any single ship. At the same time that Ship 37 was being readied for static fire testing, Booster 16, which will be paired with it for Flight 10, was also getting its final touches. In fact, Booster 16 successfully completed its static fire test back in early June. This synchronized prep of both the upper stage and booster is key to keeping everything on schedule and minimizing downtime between tests. Now, none of this would be possible without close coordination with regulatory agencies, especially the FAA. SpaceX has been actively working with them to streamline the approval process for testing and launch licenses. They've also coordinated road and beach closures around the pad for the static fire, making sure operations run safely and with minimal disruption. And here's something that really sets SpaceX apart: transparency. Unlike some companies that prefer to keep things under wraps, SpaceX has been open about the June setback involving Ship 36. Preliminary findings suggest the explosion was caused by a failure in a COPV in the nose cone. In response, the team likely launched immediate design reviews and made adjustments to Ship 37's construction and test procedures to prevent similar issues from happening again. Anyway, if you loved this deep dive, smash that like button, hit subscribe, and ring the bell. We're aiming for 150,000 subscribers, and we need you to get there. By contrast, Blue Origin is still having a tough time getting New Glenn ready for its second flight, which is scheduled no earlier than August 15th. Even though it's been 6 months since the rocket's first flight, the company is still stuck doing small component tests. On July 28th, Blue Origin's CEO Dave Limp said they were continuing to test the forward module. This test focuses on the reaction control system, which uses hydrogen peroxide as fuel. It delivers 20,000 pounds of thrust, almost as much as a single F-18 Super Hornet engine, which cranks out 22,000 pounds. During New Glenn's first flight, the RCS did its job perfectly, helping to reorient the booster within just half a degree of the target during spaceflight. Cool, right? But here's the thing. People are noticing how slow progress has been. That mid-August launch date, it's looking shaky. Some think it might actually get pushed to mid or late September, or even October or November. If that happens, Blue Origin definitely won't meet its goal of 8 New Glenn launches this year. Meanwhile, SpaceX is out here launching Starships every few months, as long as nothing major goes wrong. That kind of slow rollout has to sting for Jeff Bezos. Back in January, he said that one of his top priorities for Blue Origin this year was increasing launch frequency. And that's a big deal because, with tensions between President Trump and Elon Musk, the U.S. government is more eager than ever to find another reliable launch provider besides SpaceX. If New Glenn could actually launch regularly, there'd be plenty of business waiting. Now, on top of all that, there's the whole Amazon satellite thing. Bezos' other company has to get half of its 3,236 satellite Project Kuiper constellation into orbit by mid-2026 to keep its license. To pull that off, Amazon wants to do rapid launches in 2025 and 2026, using a bunch of rocket providers: ULA, Blue Origin, Arianespace, and even SpaceX, for a total of 83 planned launches. Sounds solid, right? Well, here's the kicker. Of the 83 confirmed launches so far, only 3 are with SpaceX. Yup, the company known for super reliable, frequent flights is barely in the mix. ULA, on the other hand, is supposed to handle a big chunk of Kuiper launches. But their Vulcan Centaur rocket is bogged down with a massive military launch backlog from years of delays. Amazon also signed up for 18 Ariane 6 launches. That rocket only just had its second flight, its first fully commercial mission, on March 6th. But it still doesn't hold a candle to Falcon 9's long track record. So yeah, given how little Amazon is relying on proven rockets like Falcon 9, Kuiper might be in trouble. And the reason behind this? It's the kind of thing we all kind of suspect. Jeff Bezos has taken heat in the past for letting conflicts of interest affect major decisions. In fact, during the early Kuiper planning stages, an Amazon shareholder even sued the board of directors and Bezos himself. The claim? That Amazon handed Blue Origin a contract without seriously considering other, more experienced players, like, you guessed it, SpaceX. Blue Origin has made some rough calls in the past, and let's be real, bad decisions are hard to walk back. But the one thing you can do? Fix your game in the present. And guess what? That's exactly what Blue Origin is trying to do now. They're picking up the pace, gearing up for 2 major missions, one to Mars and the other to the Moon, even ahead of SpaceX. Let's start with the Red Planet. So, NASA has this mission called Escapade. It's a duo of small spacecraft meant to head to Mars and study its magnetosphere, basically the invisible shield that protects the planet from solar radiation. Cool stuff. Originally, Escapade was supposed to hitch a ride on New Glenn's debut flight in October 2024. But yeah, that didn't happen. Why? Because the timing was sketchy. These spacecraft use hypergolic fuel, super reactive stuff, and once they're fueled up, you have a tight window to launch. No delays allowed. If things had gone according to plan last October, those little guys would be almost at Mars by now, starting their science magic. But since they missed the optimal launch window, now they've got to wait for the next one, opening later this year. The current goal? Launch this fall. But that also means they won't reach Mars until late 2027. Yep, that's how tricky interplanetary timing can be. But that's not all. Blue Origin has its sights set on the Moon too, and this one's even bigger. We're talking NASA's Artemis program. Enter Artemis 5, the 5th mission in NASA's Moon program, and the first time humans will ride Blue Origin's Blue Moon Mark II lander. That's scheduled for March 2030. And yeah, that feels far off. But hold on, before the crewed version flies, Blue Origin is planning a major test, the Blue Moon Mark I Pathfinder mission. This is like a dress rehearsal, an uncrewed mission to prove the system works. Think of it as a lunar road trip minus the astronauts. It's slated to launch no earlier than August 2025, sooner than SpaceX's Starship propellant transfer demonstration, scheduled for the 3rd quarter of 2026. The transit time to the Moon is typically a few days, 3 to 5 days for most lunar missions. So the landing would occur shortly after launch, assuming no significant delays. And this isn't just for show. This Pathfinder mission is built to demonstrate precision landing tech and drop off scientific payloads for both NASA and private clients. It's basically the test drive before the real thing, and if it nails the landing, that'll be a massive green light for the astronaut version in 2030. So yeah, Blue Origin's been slow out of the gate, but they're clearly trying to course correct. Moon, Mars, and maybe beyond? We'll have to wait and see. However, before Blue Origin can even think about deep space missions, there's one supercritical hurdle they've got to clear. Zero boil-off technology. Now, what is that exactly? Basically, when you're storing cryogenic propellants like liquid hydrogen and liquid oxygen, the stuff rockets love to burn, it's insanely hard to keep them cold in space. We're talking about temperatures near absolute zero. Without the right tech, that stuff just boils away over time because of the heat sneaking in from the sun or even the spacecraft itself. So, Blue Origin's working on fixing that. And on July 29th, they made a pretty bold claim. Their system is now outperforming existing standards. They've been using flight prototype hardware to maintain liquid hydrogen and oxygen at mind-blowing temps, 90 Kelvin and 20 Kelvin. That's like colder than outer space itself. If this tech actually works the way they say it does, it's a game changer, because storing propellant long-term in space is key for moon bases, Mars missions, and basically anything beyond Earth orbit. While Raptor 3 is supposed to be more reliable than ever, there's a catch, at least for now. And guess who confirmed it? None other than Elon Musk himself. In a recent post on X, he casually dropped a bombshell about the engine's startup sequence. Very complex startup sequence. Insane timing precision is needed to avoid blowing up the engine. Yeah, not exactly a confidence booster, right? Turns out getting Raptor 3 up and running is a bit like trying to perform open-heart surgery with chopsticks. Every move has to be timed just right, or the whole thing could blow, literally. It's one of the most complex parts of the engine's design, even more so than earlier versions. Here's how the whole startup dance goes down. Step 1. Super chill before ignition. Before anything even starts, certain parts of the engine need to be cooled way down. Why? Because the fuel is so cold it could crack the metal if the engine's too warm. Ice bath first, fire later. Step 2. Spin up the beast. Next, the engine's massive pumps have to kick in. These bad boys push liquid oxygen and methane into the engine, and they need to hit just the right speed. Too fast or too slow? That's a problem. Step 3. Light the mini flames. Before the main fire show starts, tiny burners, called pre-burners, need to ignite in a super specific order. They power the pumps and get the main engine ready for liftoff. Step 4. Showtime. Once the pumps are humming and the pre-burners are blazing, the main engine fires up. That's when you get that thunderous roar and crazy thrust. But here's the kicker. If anything goes even a hair off script, the whole system could fail. A burner flickers too early? Boom. Pumps a bit slow? Boom. Timing has to be pinpoint perfect, down to split-second precision. To put it in everyday terms, starting the Raptor 3 is like trying to cook the world's fastest and most delicate soufflé. One wrong move and it's ruined, or in this case, exploded. Wild, huh? Now here's where things get even more interesting. How the Raptor 3 engine is actually built. To make it lighter and simpler, SpaceX decided to ditch a bunch of traditional parts like bolts and flanges. Yeah, those old-school components are great for modular designs, but they also bring problems. Extra weight, heat spots, and more chances for leaks. So instead, SpaceX went with an almost fully welded design. Sleek? Totally. But there's a catch. By welding everything together, the engine becomes super strong and less prone to leaks. The downside? You can't just pop it open if something breaks inside. Elon Musk has openly said it. Once it's welded, you can't easily take it apart. If a part deep inside goes bad, technicians have to literally cut into the engine, like surgery with a chainsaw. That not only messes with the structure, but it also takes a ton of time and effort to fix and reassemble. And that kind of repair job doesn't really fit with SpaceX's big goal: quick turnaround. Starship's whole idea is fly, land, refuel, repeat. No long pit stops. But if fixing the engine means taking a blowtorch to it, you're not exactly turning things around quickly. So what's the solution? Build the engines so well that they don't need fixing. That's the dream anyway. The problem is, in real life, stuff breaks. So now we've got two big challenges on the table. 1. The crazy complex startup process. 2. The good luck fixing it welded design. These are the trade-offs SpaceX made in chasing high performance and simplicity. And honestly, there might be even more hidden challenges we don't know about yet. We'll only find out with more flights. And don't forget, Starship doesn't just use one Raptor engine. We're talking dozens working together on both the booster and upper stage. That means every single engine has to start, run, and shut down in perfect sync. The more engines, the more things that can go wrong. It's a logistical ballet with rockets. SpaceX is also trying to tick all the boxes. Reusable, cheap to build, and easy to mass produce. But juggling all those priorities makes designing and running these engines even tougher. Bottom line, if these issues aren't solved, there's a real chance something could go wrong, either during startup or mid-flight. And Musk has been pretty upfront about that risk. Still, the Raptor engine isn't just a fancy piece of tech. It's part of a much bigger mission. Musk believes pushing boundaries in engineering, like making better rockets, is way more impactful than getting tangled in politics. His vision? Use tech to solve huge problems, like colonizing other planets and boosting the global economy. Basically, he wants to build stuff that makes the world, and maybe Mars, a better place. Big risks, big dreams. That's SpaceX for you. The shift to the Raptor 2 engine was a major milestone in Starship's evolution. Why? Because Raptor 2 delivers more thrust, 230 tons at sea level, compared to Raptor 1's 185 tons. It's also more reliable and cheaper to build, thanks to a much cleaner, more streamlined design. SpaceX drastically reduced the amount of plumbing and merged several valves into simplified valve plates. This cut down on failure points and made the engine more resistant to heat and flames. Welding components together instead of using bolt-on flanges shaved off weight and improved the engine's structural strength. The old ignition system in the combustion chamber? Gone. Raptor 2 now uses a hypergolic mix of hot oxygen and methane under high pressure and temperature for ignition. That change eliminates redundant igniters and simplifies the whole system. They also redesigned the combustion chamber to be more stable and removed unnecessary internal baffles, making engine performance more robust and consistent. All of this follows SpaceX's core design mantra. The best part is no part. Fewer components mean fewer things that can go wrong. Manufacturing gets faster, simpler, and more reliable. SpaceX started integrating Raptor 2 into Starship builds in late 2021. Since the first flight on April 20th, 2023, the engine has seen real-world action. While it shows clear improvements, it's still a very complex system. Managing 33 engines firing together on the Super Heavy booster has proven difficult, with issues like pogo oscillations, loose fittings, and control system bugs still popping up. Flight 10 will also use Raptor 2, and after all the data collected from previous launches, the hope is that it will perform more smoothly than ever. That's key, because these lessons are laying the groundwork for the upcoming Raptor 3 engine, which will debut on Starship version 3 prototypes, Booster 18 and Ship 39, set to fly on Starship Flight 13. Both vehicles are in the early build phase, with visible parts already hinting at progress. In early July, we spotted the new version 3 booster landing tank, which is set to be installed on Booster 18, now stationed at the Mega Bay. The version 3 landing tank includes a forward lift point and an aft breakover, improvements aimed at simplifying the lifting process and how the booster is handled during operations. The B-18.1 test tank was also seen at Massey's test site, although it may have been damaged during the Ship 36 anomaly on June 18. That could delay further tests and production timelines for Block 3 hardware. As for Ship 39, details are scarce. If anyone has updates, now's the time to share. Once both Booster 18 and Ship 39 are fully stacked, the real prep begins: cryogenic testing, structural checks, and finally, installing the Raptor 3 engines. That will mark the true arrival of Raptor 3, not just a concept anymore, but a flame-tested engine ready for liftoff. Its debut will validate years of work and shape the course of SpaceX's journey for the rest of this decade. Most importantly, Raptor 3 is set to greatly enhance the reliability of SpaceX's Starship. Like Raptor 2, it follows a minimalist design philosophy, stripping away much of the intricate pipework and fine detail found in earlier versions. But Raptor 3 goes even further, adding a secondary cooling loop to better handle the extreme heat and pressure during operation. This clever upgrade removes the need for external heat shielding, which helps cut down the rocket's overall weight. This simplified architecture is more than just aesthetic. It sets the stage for faster manufacturing, easier refurbishment, and significantly improved reusability. SpaceX is aiming to produce each Raptor 3 engine in just 48 hours. With fewer parts and more streamlined assembly, there's less room for error, which means better quality control and fewer defects that could cause engine failure. Performance-wise, the engine's clean and robust design makes it easier for engineers to fine-tune combustion, pushing the limits of what it can do. We're talking about higher thrust, better specific impulse, and the ability to operate under even more intense chamber pressures. Initial tests showed Raptor 3 hitting a chamber pressure of 350 bar, producing about 269 tons of thrust, with a dry mass of 1,400 kilograms. But newer data is even more impressive. Raptor 3 now achieves 280 tons of thrust at sea level, and a staggering 306 tons in vacuum. It also reaches a vacuum ISP of 350 seconds, ranking it among the best-performing engines in its class. While the mass has increased slightly to 1,525 kilograms, its power-to-weight ratio is still superior thanks to the leap in performance. All of these upgrades allow Raptor 3 to fix many of the issues that held back Raptor 2. It's expected to improve every phase of Starship's flight: liftoff, orbital maneuvers, re-entry, and landing, by delivering more consistent and reliable performance. These are all areas where Raptor 2 had its share of struggles, especially during version 2 test flights. With Raptor 3, SpaceX is ready to push further and take on missions that demand more from their launch system. What's also exciting is that Raptor 3 directly benefits from the trial-and-error development path that SpaceX is known for. It incorporates hard lessons learned from Raptor 2's growing pains, things like hot gas leaks, unplanned engine shutdowns, and turbopump issues. Fixes for problems like loose flange fittings and fastener preloading have likely